Alright, for this question, we are looking at the heating curve. So it's important to know for heating curve which part of the curve refers to heating out of the object and which part of the curve refers to a change of state in the object. So in this heating curve, you can see that segments Q and S, these lines are flat and horizontal. This means that at in these two segments, the temperature remains constant, and this must mean that there is a change of states happening, and Q comes before S, so it means that for segment Q, it is about the material melting, and for segment S, the material is boiling, in changing its states from liquid to gas. So for part A of the question, at which stage does the substance undergoes the largest increase in volume? It must be during the boiling state, because from a conversion of liquid into gas, we require the particles to move really very far away from one another, and this is the reason why during boiling there is a massive expansion, massive increase in volume. And we all know that for gases, they occupy a very big volume, and this is the reason why when you apply kinetic particle theory to understand what's happening during boiling. For part B, identify the stage where the kinetic store, energy in the kinetic store remains constant. This must be during the change in states, which is segment Q, where melting is happening, and segment S, where boiling is happening. The microscopic reasons for this you will see in the answer for part D later on. For part C, 3 stages where the substance is not in a mixture of different states. So this must be in segment P, R, and T, because in segments P, it is the solid substance heating up its temperature, so it remains a solid throughout segment P. Segment R is the substance in a liquid state being heated up, and segment T, in gaseous state, the substance is being heated up. Now, in segment Q and S, or in any change in state during boiling or during melting, the material always remains as a mixture of the two states. So for example, during melting, you will see that there is solid inside and there's also liquid inside. Just take, for example, ice cube and water. When the ice cube is melting, it becomes water, and there'll be a mixture of solid ice and liquid water, and the temperature will remain at 0 degrees Celsius when the ice is melting. Now for part D, these are the various reasons. I think the gist here is number one, knowing what internal energy is. Internal energy is the sum of the kinetic energies and the potential energies of the particles in the system. So as long as there's a change in kinetic energy or there's a change in potential energy, then the internal energy of the system will change. That's the first idea, to understand what exactly is internal energy. Now, the second thing is you need to also know microscopically what affects kinetic energy of the particles and what affects potential energy of the particles. So kinetic energy of the particles is related to how fast the particles are moving. If the particles move faster and vibrate faster, then there's more kinetic energy, and a consequence of higher movement or higher kinetic energy is that the temperature will change. So as long as you see any temperature change on the heating curve, it must mean that kinetic energy would have changed, and therefore internal energy would have changed. Alright, then lastly, let's talk about potential energy. Potential energy relates to how far apart the particles are. This is what you learn in chemistry also. So if we do work to pull the particles apart, we are increasing the distance between the particles. This means that we are giving the system energy for the particles to be stretched far away from each other, and therefore when this happens, there is more potential energy in the system, and therefore internal energy will change. Another example for this is actually just melting or boiling. In boiling, we provide energy from the fire, and this energy goes into the system in the form of potential energy, because it pushes and makes the particles move far away from one another. And this is the reason why from liquid to gas there's a massive expansion, because the particles are far away from one another. So these are the three key points for this question. You might want to replay this video because there's a couple of concepts here, and also pause the video so that you can jot down the explanation for each of these states.